All right, here we go. 3, 2, 1. Hi, this is Bill Evans, and this is my book, Category 7. I hope you'll give it a read, and I hope you'll give it a listen as well.
Ladies and gentlemen, please welcome. Well, we're very honored that Bill has joined us today, and I thought we had a category 2 about 4 o'clock today. I guess in the city you had a sort of different kind of category yesterday with the steam and the tornado. And the tornado, but you're very busy. But the concept of category 7, if you haven't read, is, I'm sure Bill will talk about it, but it's about a superstorm that will ultimately hit New York City, or might hit New York City every 70 years. Is that what you said?
That's right. Yeah.
And it's a fascinating concept, and I think he's also won another book already. You know, he's a first-time author. He's already in his 2nd book. Yeah. But hopefully you'll this group here will get you the New York Times bestseller list.
I hope so. Just at the bottom.
But thank you, Bill, for coming out.
Thank you so much for having me. It's an honor.
Thank you for coming out.
Thank you very much. I never get to sit and talk. Is that okay? I can stand and talk. I stand in front of weather maps a lot. But I want to tell you a little bit about my book and why I wrote it and how it came to be. I didn't know anything about the publishing world, really. And I moved to New York City in 1989. I took the Staten Island ferry from Manhattan over to Staten Island just to see where everything, the lay of the land. And I noticed that everything sat on water in New York City that's vital to life. Wastewater treatment plants, airports, subways, trains, your drinking water facilities, power plants, airports, all this sits on water. And having grown up in the southern United States, and I grew up during one of the most terrible hurricanes of all time, our generation anyway, Hurricane Camille in 1969. Destroyed our farm, wiped it completely off the face of the earth. We had beautiful, as they say in the north, pecan orchards. And you couldn't even find a pecan after the hurricane went through. So as a 9-year-old child, I was really awestruck by hurricanes. And as I'm taking the Staten Island ferry over, I look back at the Jersey Shore and up the Hudson River and Manhattan and the East River and Brooklyn, Queens, and Long Island, Governor's Island, and I'm thinking, wow, what a place for a hurricane. I was thinking, man, it would be unbelievable what a hurricane would do here. So I went back and looked at all the records from hurricane keeping back into the 1400s, the time of Columbus. The great sea captains, they kept logbooks of all these hurricanes that took place, and found out that since the 1400s up until the present, if you take the top 20 hurricanes of all time from 1400, 1/3 of them happened right here in our area. And the reason why in this mass media age that we live in now, you know, the instant point-click information, is that every 70 years a major hurricane hits this area. Major being a category 3 and higher. So 10 years ago I thought this would make a great science book. I'll research the architecture of New York City. You know, what were the Roeblings thinking when they built the Brooklyn Bridge and all the bridges in New Jersey and their headquarters down in Trenton? And what were the architects thinking when they built the subway system in New York City? Were they going to make that hurricane-proof? Was it going to be flood-proof? And then I went back and looked at all the great hurricanes that hit New York City. And put all this together, and I thought, I'll make a science book. And as you know, in publishing, publishers that I went to lunch with said, you have a great idea, you have a wonderful idea, it'll make a great book. It just will not make a great science book. Because about 6% of readers read science books. I go, but I love science books, I can read them all day. But I'm a scientist, you know, that's what we do. I can pore over all the extremes and numbers and temperatures and charts and graphs. Love that stuff. So I figured then, I've got to figure out a way to educate through entertainment. So I found a wonderful co-author in the form of Mariana Jameson. She has written books for the Defense Department, for the CIA and the FBI. She wrote books on bombs and guns and spying on the internet and all that sort of thing. So I knew she could take something complex as being able to manipulate weather and work with me. And we collaborated. We came up with characters, and we came up with character arcs, and gave them lives and meaning and purpose. And then we put them into situations, and we had to make decisions and turn this into a rather, what I feel is a wonderfully entertaining novel. But at the same time, you learn a lot. You learn about our area and what a hurricane would do here in New Jersey, as well as New York City and Long Island and Connecticut. I had the most fun writing this book. I had to put it on the shelf for a little while because of 9/11, and then Hurricane Katrina came along, so I kind of waited until the time was right to release it. And now the time is right to release it. We're 1 year away from the 70th anniversary of the 1938 hurricane, which hit New Jersey, New York City, and Long Island. So we're 1 year away from the 70-year mark that we have in weather. And the reason why we use these 70, 100-year marks in weather is because weather repeats itself. Weather patterns repeat themselves over and over and over and over again. So what has happened in the past will happen again. And we will have another hurricane of the 1938 storm, which was a Category 3. It was called the Long Island Express. They didn't name hurricanes in those days. And so the weather patterns that repeat themselves, they happen again. And we'll have another hurricane. You and I sitting in this room, we'll see one in the next 20 years that may not be a Category 7, let's say, but it will be a very strong storm in the area. We've actually had a Category 7 storm. Before the Saffir-Simpson scale, which is that scale of 1 to 5 came along, there was no scale. But Hurricane Camille had winds of 189. Hi, how's it going? How you doing, Duffy? Nice. That's my captain who's pulled me all over New York Harbor behind her beast. Water skiing. And I still have one good leg.
Sorry about that.
That's okay.
One wrong turn, they hold it against you.
You know, the Titanic captain was an aging guy on a new boat, wasn't he? So Hurricane Camille actually had winds of 189 miles per hour. It was a Category 7 hurricane at that stage in time in its career. So I'm so glad you all came tonight. I'm willing to answer all your weather questions. I'm sure there's something new that I haven't been asked. We can talk about any weather discussion you want to talk about. In this book, if you haven't skimmed it or anything, it's about weather manipulation, about hurricane hitting New York City, about our United States government has been involved in weather manipulation since the Second World War and during the Cold War. You may have seen this story yesterday that came out that says China is going to be manipulating weather to aid and benefit the Olympics coming up in Beijing. They're going to fire rockets into clouds to keep it from raining, and they say they have done it in the past. I did read a very interesting part of that story, which the meteorologists said they were very worried and were sweating. The government had called them and said, do something about the weather. Do not make it rain on the day that we're having these governmental parades and all this stuff. So what that meant to me was, if you're the meteorologist and they called you and said, don't let it rain, and it rains, somehow you get executed. In our business, we call that weather behavioral modification or weather behavioral motivation, whichever way you want to look at it. So any questions tonight on weather? I'd be glad to debate, talk about anything. I've been asked some really great questions. Yeah?
Does global warming...
Oh, right out the bat! It's going to be that kind of night.
Does it make a difference in the timing of the southern hurricane?
Doesn't make any difference at all to hurricane season, hurricane development, nothing like that. Global warming, or the climate change, or the warming of the planet, has no bearing on hurricane season. What the scientists, the guys that make those forecasts on hurricanes, look at when they do that, they look at the thunderstorms coming across the African plain. They look at the Sahara dust storms that are in the African plain. They look at the intertropical convergence zone. That's the coastline of Africa and the winds that come out of the northeast across. So they create little pools of low pressure systems in the atmosphere that you don't even see. And the thunderstorms come across the African plain and they merge with those waves of low pressure in the atmosphere. That creates the beginning stages of what would be a thunderstorm, low pressure complex that eventually becomes a tropical depression. The other thing that the scientists look at is the El Nino. We don't have an El Nino, we have a La Nina. That's a relaxed pattern in the Atlantic. El Ninos tend to create wind shear that cuts off development of tropical storms, tropical depressions. The other phenomena that we look at is called the thermal haline cycle. That is the current or conveyor belt of warm water that comes up from the equator, comes up into the central Atlantic, comes up into the northeast United States. And that conveyor of warm, salty water displaces the fresh water that comes down from the Arctic Circle. So you have that Gulf, that stream, that conveyor, that Atlantic Ocean current coming up, the colder waters in the northeast, it displaces that. And that's why we see what's called warmer SSTs, warmer sea surface temperatures in the Atlantic. And that's what we have right now. So all the ingredients are there for a prolific, above normal, multi-decadal weather pattern of above average storms of what we're looking at. And that's where we are. As we go toward the end of this month and we get into August, we're starting to really get into the peak of the season. And we'll see what happens. All the conditions are favorable for activity out there.
I listened to your interview with John Gambling last week, which was excellent.
Oh, thank you.
And you talked about global warming itself, and
Right.
you did not feel that it was, that man really contributed to global warming?
No, I don't. Well, and I'll base that on this. I'm a scientist. I look at data. I look at the raw data. You know, you take away an agenda to your left and you have an agenda to the right. I don't see much of an agenda on the right, but I really get bombarded more from the left. But and that is for a lot of different reasons. But if you look at the empirical data, there is no empirical data whatsoever that shows anthropogenic, that's man-made, anthropogenic production of CO2 is contributing in any way to the warming that is going on the planet. Period. There is none. So if someone tells you I have proof that there is man-made, man is bad, man is sinful, creating carbon in the atmosphere, it is not true. There's no data whatsoever to support that. The planet has actually been warmer in other periods of time. In the Middle Ages, the planet was far warmer from CO2 than it is now. Do you know anyone in this room know what the #1 producer of carbon dioxide is in the atmosphere? No. No.
Forest fires?
No.
Cows.
No. Stop blaming cattle. Defenseless animal. No. See, all these things we've been trained that we've heard about in the media. The #1 producer of CO2 in the atmosphere is the ocean. Water vapor. Warmer atmosphere means more water vapor. The oceans are creating, and always have created, more CO2. Now, the computer models that the global warming theorists like to use do not even include the oceans. So how can you have an aggregate or an accurate model if you don't include the entire planet? How can you blame man? It seems like to me that all the blame gets levied is at all the developing countries. No one's blaming any other country. But we were a much more of a livestock world, a more agrarian society, 100 years ago. And there is a lot of CO2 produced from cow and livestock burps and gas and all that goes into the atmosphere. There is a lot of that. But when you look at the amount of man-made carbon in the atmosphere, there's really no numbers to support that. That the CO2 is a lot of things. If you have the ocean producing moisture all the time, which it does, the Earth is now 67% water. Almost 70% water is the Earth. So you have a lot of moisture that comes off the oceans. There's been great studies that have been released about the sun. And this year has been a phenomenal year for sun research. We found that the sun is not a universal sphere that sends off glowing heat equal distant around that sphere. It's not true. We found that there are solar flares, there are solar storms, there's what are called massive mass coronal ejections. I want to make sure I got that right, because if you have a long weekend and try to say that on Monday, you can get that wrong. Coronal mass ejection. We've really noticed that in the last few years because it interrupts all of our communications that we use now in between satellites. So that prompted these studies. We found that these flares heat different parts of different planets in different places. We're also finding that Mercury and Venus are warming somewhat, the astronomers say. They're saying that Jupiter is warming somewhat also. So we're not the only planet that seems to be having climate change, and there's some warming in different places. It's true that the Atlantic Ocean has warmed, but also at the same time the Pacific Ocean has cooled. It is true that the Arctic Circle is getting smaller, but it's also true that the Arctic Circle is getting larger. So the planet balances itself. So those are the things when you talk about climate change and all these things that are about global warming. Trust me, as a meteorologist and a scientist, I can tell you, you have a bigger chance of seeing a hurricane rolling up Route 17 than you ever will of being harmed in any way by global warming. You know, I'm a believer, I'm a person of faith, and I firmly believe that the person who created this planet, the great creator, will not let us harm it. Even though we're trying to do all these great things to improve our lives and improve ourselves, I don't think the person that made the planet is any way going to let us harm it because we're trying to better ourselves. So the global warming debate has been going on for 100 years. There's a great story that is out, and you should search it. These two guys did a story about mass media and global warming for past 100 years. It's a very interesting read about all the dichotomy around global warming and mainstream media, how it has all been produced and written about over the last 100 years. My favorite thing to show my interns, because they're so bombarded by media and global warming, and you watch MTV, and I watch all this stuff, is there's on YouTube a documentary made in 1958. It's called Global Warming 1958. And if you take a look at that, it's actually directed by Frank Capra. And in the late 50s, DuPont and GE, they paid for these documentaries about science to be produced. And if you go and look at that, there's a scientist talking about man's sinful nature and wastefulness and putting all this stuff into the atmosphere, and you see a shot of a factory with white smoke coming up, which is steam, not pollution, and a whole bunch of things. But the funniest thing that I captured was there's a cartoon where they said, there'll be glass-bottom boats. This was 1958, okay? There'll be glass-bottom boats floating over Miami, looking at the city below. Well, here we are 50 years later, and Miami is sitting there just like it was 50 years ago. So do we need to be good stewards of the planet? Yes. Do we need to move away from fossil fuel burning and go to alternative sources of energy? Absolutely. Do we need to keep our planet clean and be good stewards? Absolutely. But in the global warming debate, as a scientist, I can tell you there's just nothing there. Man is putting things into the atmosphere. China just surpassed the United States as the biggest CO2 producer on the planet, if you want to look at that. But if you just take a look at a pie and look at what percentage that is of man-made, it's relatively 10% and under to 6% of the whole pie of all the greenhouse things that go on the planet. When you add livestock, the ocean, the sun, and all that sort of thing. That got the room quiet.
I've got a question, Bill. You're either the most loved man or I guess the most chastised man given your day-to-day job as meteorologist. Is it more difficult today than it was when you first broke into the business to predict weather? Or
There's more pressure now to be accurate 10, 15 days out than ever before.
Because people have access to AccuWeather
on
the computer, so they expect if they're going to have their golf game on a week from Saturday,
right,
that you said it's going to be sunny.
Yes.
They're making their plans. I mean, do you hear back?
Oh, sure. You kidding me?
People?
That's the beauty of being a weatherman in New York City, is that you get feedback right on the street the moment you walk out of the building. And I know when it's bad when it usually starts with, "Hey, freaking idiot!" And I know what's coming. See, I don't mind that. I don't mind debate. I think what happens with weather now is that you can go online and you can see these forecasts that are put out on websites that are 15 days out, day-to-day high and low number temperature. Now that is put out by a computer model that we have here in the United States, or we're looking at the Europeans, depends on which model they pick. And just because they put that, I hate those because it's just a little graphic and a temperature. That is not the gospel, okay? Especially when it's run out 15 days. I mean, we have these computer models that go out 15 days, and generally past 5, they're not that great. They can give us a hint at what we're looking at 15 days out. But I always tell my meteorology interns, computer models are for guidance only, not forecasts. So when you look at those things and they're going out that many days, generally we're 5 days is still plenty at this point. We're extremely good, 48, 72 hours out, 3 days out. But some of these models can hint to things that are coming. One of the computer models we had this winter, which is also frustrating for meteorologists, is every 15th day, 14th, 15th day, we put a blizzard. Now, you think about that. I'm a meteorologist, and I've always looked at myself as I'm a public servant. As it was pointed out to me, he said, nobody wears a coat and tie that nice that's a public servant, but that's just not true. But my job is to help people. And, on the 15th day, you would like to be able to go out on television that night and go, hey, 15 days from now, just so you can get ready, we're going to have a blizzard. But I know with the infallibility of these computer models, I can't go out there and do that. I would like to, because I know we get to the 15th day, and I walk out on the street and it's, hey, freaking idiot, where's the blizzard? So that's the beauty of living here, is you get instant feedback, which I don't mind at all. But being a weatherman is a great job. It changes every day. That's why I wanted to do it. I started in radio when I was 13 years old, and when I was 17, I had my first television job as a weatherman on the one station we had in our town. I grew up in Mississippi, and I did the weekend weather because I just loved it so much. I convinced them to give me a job. And I had no meteorological training, and one weekend we had a severe outbreak of tornadoes in Mississippi. And I was on the air, and while I was standing in front of the weather map, we didn't even have computer. I'm pretty old, I know I look young. We didn't even have computers then to do weather. And it was either lick symbols and stick them on a board of the U.S., or you had magnets, or you drew with a magic marker, dry erase marker or something. And I realized I was thinking in my head, Bill, you really don't know anything about tornadoes. So I went to meteorology school and got a degree in meteorology and learned about the weather and the atmosphere and how it all works, and moved here, and I love it. And I love coming to New Jersey. I was down in Ocean County last night for a signing, and I did the Garden State Plaza a few days ago. I love coming to New Jersey. We come to Cape May every month. Every August, I should say, not every month, but every August. And we bring the kids, and we'll be going down there this August. So I love coming to New Jersey. I equate more with residents of New Jersey than where I live in Connecticut. So, any other questions? Yeah, yes, sir.
Yeah, I met you a couple times and spoke to you on the phone last summer.
Was I nice?
Oh yeah.
Okay.
Your ABC.
I was a jerk.
Your ABC softball team played our fire department up in Suffolk.
Okay, that's it. Yeah, I
I spoke
remember
to you on
that.
the phone last.
That's right. Yes,
in the lobby of
absolutely.
the ABC building. I know you're on the radio too, PLJ.
Right.
Joe Nolan. He looks like the Pillsbury dope.
Yes. Oh, absolutely.
Friends for years.
Sort of like a Weeble.
Yeah.
You still sell Weebles in the toy He's a great guy. He was the best man at my wedding, and I was the best man at his wedding.
One other quick question. Gloria Stokes. She came from Cleveland. Was
Yes.
her father mayor of Cleveland one time? There was a Stokes back in the late 60s.
That was her uncle was the mayor of Cleveland and went on to be the first black news anchor in Cleveland.
Yeah.
Her dad was a U.S. congressman and started the Congressional Black Caucus.
Because her uncle then came to NBC.
Yeah, Earl was in Congress for 35 years. A Democrat. Back when they were fine Democrats. Kennedy Democrat. Yeah, somebody got a question over here. Go ahead.
Hey Bill, have you ever chased a tornado for reporting the news?
Yes, absolutely. Chased tornadoes on several occasions in Oklahoma and in Texas. And that is a pants-soiling experience. That really, really is. We still don't, we can find them, look at them, but, now the technology to chase these tornadoes, is just wonderful. You can take a van and you can outfit it with a Doppler radar, and you can find where the hooks are in the atmosphere, the bow echo in the cloud, and you can follow it along, even though it hasn't reached the surface. Sometimes they never reach the surface. That little part about why they spin and get down to the surface and what triggers that is still a great mystery in a mesoscale thunderstorm. We don't know why that happens or when it's going to happen. So when it happens and you're looking right at it, it takes your breath. So yeah, I have done that. It's quite exciting. And actually, residents can do that now. You can go down to Oklahoma. They're tornado chasing companies. They'll take you in the vans, and it could be, yeah. Ticket back is in a pine box. So in the back, yes, sir.
Bill, what's the biggest reason for missing a forecast? Is it wind? I mean, like a day off, you call for a rain?
Well, usually forecast is because there's so many elements that go into a forecast. Some nights you can look at, there's so many things going on that, I have roughly 3 minutes, and there's two schools of thought there. I like to make a forecast, make a decision, take all this big pile of data, and make it into a forecast, and go with one idea as to not confuse the audience. I really never wanted to stand out there at night and go, yes, we have cold air from Canada, we got warm air from the south, we're going to have a maritime breeze in the afternoon, but we're also looking at scorching heat in the Ohio Valley, and all that's coming to our house, And if you stand out there and you confuse too much, I generally like to go with one idea, and rather than saying, well, this is what we think based on this scenario, and this is what we think based on this scenario, and this was what we think based on this scenario. And by the time you get 2 or 3 scenarios, the audience is just bamboozled. So I like to have one idea. So generally the nights that we bust on a forecast is because of the region where we live is a great place to bust on a forecast. Because we live so close to the ocean with a maritime influence, so close to Canada with cooler air or colder air and frontal systems coming out of the north. And then we have frontal weather that comes from across from the west, from the Great Lakes to the Ohio Valley. And then we have lows that come up the coast from the Gulf of Mexico. So how'd you like to deal with that all in one night? So that's why sometimes we bust on these things as to when we're going to get rain or we don't get rain, or we get snow, we don't get snow. A lot of elements that are involved, and you're trying to go and forecast out. Also, the computer models that we use run 4 times a day. Now, as computers, you're talking about putting a massive amount of information. The Cray computer that is used in the Pentagon to put all the weather information from, around the world. We use information from around the world because the Earth is what we're forecasting with. We just don't start with the Pacific coast and go, okay, that's there, and we come across. We have to use the world. The world is a total fluid dynamic. And so 4 times a day, these computer models take a slice. So imagine a pie, and you take the thinnest slice of apple pie that you can. It's a snapshot of the fluid atmosphere flowing. Atmosphere's flowing, snap, atmosphere keeps going. We take that one snapshot, put it into a computer, run that out 15 days, and that's our 6 a.m. model run on computers. And then we do it at 1 in the afternoon, and again in the evening, and again at midnight. So we do that snapshot 4 times a day. All this time, though, the atmosphere is still running. So eventually, these computer models will get to where you can take the snapshot instantly, run it out, and snap again, and snap again, and snap again. But you're talking about all these weather sites around the United States and Canada and around the world being put into a mainframe computer. So that's what you're looking at with forecasting. And then you have different meteorologists' opinions. At night, I look at the forecasters from Boston. I look at the guys, what they write down in Philly at the National Weather Service office, the guys in Binghamton, and the guys in New York City, out of Long Island, at Upton. Sometimes you get 4 different opinions from those guys. And then I'm sitting there going, holy crap, now what am I going to do? So that's generally when we bust, is a lot of uncertainty in the weather forecast. And you try to explain that in the forecast, but one night, I went out there to explain the dew point and how that works. And the dew point is a measurement of moisture in the atmosphere. If the temperature is 72 and the dew point is 71, it's going to rain. If the dew point is 50 and the air temperature is 72, it's going to be dry. So I explained this on the air one night, and after the newscast is over, I go back to my office, the phone is ringing, and a guy from Brooklyn's on the phone. And Tony says to me, "So Bill, like that dew point, is that the point you do something?" So, you know, I don't explain the dew point anymore. So here's the dew point, that's it. In the back, you have a question?
Actually, Bill, I just wanted to ask
Good.
you, how many people actually forecast the weather, and how many people just use what the National Weather Service hands out every day?
Well, I think if you have a person who's a meteorologist and has been to school, or they have an AMS seal or something like that, an NWA, they've had some training. So they're more inclined to, you know, look at the data themselves, come up with what they think is a forecast, and then look at the National Weather Service, or if they're consulted by AccuWeather, or if they're consulted by another private meteorology company. I think a meteorologist is more inclined to look at all the data, because you went to school and, you know, and they taught you how to do this, and they beat this into your head in college, and it's not easy. You know, it's you know, atmospheric dynamics is difficult. At least it was for me. I hired tutors, so to get through the trig and the calculus and the analytical geometry and the upper level dynamics. So if you're going to go through all that in the synoptic meteorology and learn all that stuff, then you'd really like to put it to practical use. So I think where you have people who are just weathercasters, they're more inclined to just take the National Weather Service forecast, or if they're consulted by Weather Central or WSI or AccuWeather and these other, and just use what they use. I like being a meteorologist for that very same reason, because I talk to a guy from AccuWeather every day, and then I look at what the National Weather Service has, and I read what some professors from Michigan State have, and University of Oklahoma, and University of Florida, and then I look at what the Miami guys have. So I read a lot of guys' stuff and try to come up with the best forecast. So I think it is, you know, nowadays it's so nice that every person in weather, generally, close to it anyway, has got some meteorology training or has a meteorology degree. I don't even take an intern anymore that's just in broadcasting. I get broadcast kids call me all the time, "Well, I'm thinking about weather." And I say, "Well, you thought too late," because I have so many kids in the office now that are in meteorology school. Every kid now, weather's popular now. And every kid coming out of school now has got a meteorology degree, which is great for our society. You know, some of these guys in broadcast are really, really good. But, you know, we lose a lot of them to is private meteorology and to Wall Street. I have an intern a couple of years ago, came right out of interning for me, decided he didn't want to be behind a mic or in front of a camera, and he went to work for Wall Street for Merrill Lynch, and his first year he got a $200,000 bonus. So imagine going from eating out of boxes of mac and cheese in college and getting a bonus like that. Now that's very low by Wall Street standards, but for, you know, a 22, 23-year-old person out of college, that's a great bonus. I mean, that means he did great weather forecasting at the same time, and they gave him a little piece of every commodities deal that they did. He works for Merrill Lynch. So there's a lot of that. There's private meteorology, there's universities, there's grants, there's government meteorology, but a lot of our best and brightest minds are not going into government meteorology, and that whole culture has got to change in our society. And you see that going on down in Miami at the Hurricane Center. The prisoners are running the prison. So I was very distressed to see that because for the first time they had a hurricane director that was really going to change the whole culture there and change NOAA's perception of how the National Weather Service should be run. But the forecasters rebelled, and the forecasters won. It's an upheaval down there. So it's really terrible to see that happen. But it is our National Weather Service is going to go through some changes, and they've got to change the culture of how they operate, just their basic operation, because they're losing a lot of great kids who are meteorologists to other parts of society. I have several kids now that trade energy on Wall Street. You know, this is why gasoline prices are going up. These contracts get traded by these guys on Wall Street, and energy contracts are traded by Wall Street, and so these guys are pouring over all that stuff, and they're making a great living at it, and they're enjoying their life. And so some of our really good minds are in private meteorology right now, not with the government. That's not to say that we're in any danger, by the way. Just say it was very interesting. I'll put it this way. I thought it was very funny that all the forecasters at the hurricane office went right to the Miami Herald, and I thought they were kind of crying and whining and moaning a little bit. But during hurricane season, if there's a hurricane and I call down there and want to talk to one of those guys, I can't find one of those guys. And so when they had a little disagreement, they went right to the press.
I've got one final question. Then we'll time for questions. In the back there?
Yes?
How exactly does a hurricane form?
That's a great question. Most hurricanes start as a low pressure system, and a hurricane can only form over water because it's what we call a latent heat pump. The hurricane forces energy into the ocean, and that energy spreads out and rises back up into the storm itself. So as the hurricane is moving counterclockwise, it's constantly pulling this warm moisture spiraling up through it, through a cord from the ocean to its very top. It has to live over that warm ocean water. The biggest hurricanes of all form in an area called the Intertropical Convergence Zone that's near the Cape Verde Islands on the west coast of Africa. Thunderstorms come across the African plain. They meet these little pools of low pressure system formed in the Intertropical Convergence Zone, and where the two meet, they form a low pressure system of thunderstorms. So if you look at those satellite loops that go from Africa across to the Caribbean and the Gulf of Mexico, you'll see a band of thunderstorms. Well, eventually in that band of thunderstorms, one of these little pools will meet that and create a low pressure system, and you will start to see that turn counterclockwise. Then that grows from a low pressure storm system and thunderstorms to a tropical depression, the winds of 35 miles per hour. It continues over the warm ocean waters, which are around 88 degrees, and then 45 miles per hour becomes a tropical storm. It increases in forward speed and also increases in size, and the winds get to 74 miles per hour, it becomes a hurricane, and that's a Category 1 storm. And you have the formation of a hurricane. They always are on east to west tracks across the Atlantic. Sometimes they do form in the Caribbean from a group of thunderstorms, or they'll form in the Gulf of Mexico. Our biggest fear is that they form right at the coast and explode and then come inland over huge population centers. And that too has happened in the past as well. They're a big producer of freshwater inland flooding, and that's our biggest threat here in the town, is that where you live, where the flooding is going to be. More deaths in hurricanes these days are not caused by the storm surge, they're caused by freshwater inland flooding, 10, 15 inches of rain. For heaven's sake, we can't handle 4 or 5 inches of rain around here. Try Route 4, Route 17, and you spill a cup of water. It's unbelievable. So that is our biggest threat. I don't think that in a hurricane that comes here, you're going to have this storm surge is not a problem here. Storm surge is going to be in Manhattan, and Long Island and Roosevelt Beach and all that. The water in a Category 3 hurricane, for instance, goes up over the terminals at JFK Airport. It goes up to the top of the pedestal of the Statue of Liberty. It goes inland into, this has done this before, so this is how we know this. It goes 22 feet into Manhattan, takes it all the way past City Hall to Canal Street. Manhattan not only gets flooded from the south from a hurricane, in Brooklyn and Queens as well, but Manhattan and Brooklyn and Queens also get flooded from the north when the storm leaves, because the winds come back around from the north when the storm leaves, and it gets flooded by the Harlem and the East River and western Long Island Sound. So that's where the storm surge goes. Remember in 1938 on Long Island, there were only 200,000 people that lived on Long Island. There were 700 people killed in that storm. We lost every Dutch elm tree in New England. There are no more Dutch elm trees. Tens of thousands were lost. Now there are 3 million people that live on Long Island. You add that she Hamptons out there with Puff, Coney, Daddy Puff, and all that out there, and that adds almost another 1 million tourists out there to the eastern end in August during the peak of hurricane season. So my advice is to just make a plan and be prepared. You know your home better than anybody else. You know when you get flooding rains what happens around there. So make a plan for that. If you have to evacuate to another place or a place of higher ground, or if you got streams and creeks around your home and you know that you're gonna have to get out, make a plan for that. Because when a hurricane is coming to our area, it is totally different from a storm in the Gulf of Mexico. A hurricane in the Gulf of Mexico moves 7 to 12 miles per hour. A hurricane, when it's coming to the northeast, totally different. It's racing forward at 45 miles per hour. So the storm, when it's off the coast of North Carolina, will reach New York City, and of course will be reaching the Jersey Shore prior to that in 48 hours. So the mayor of New York City's got to make a call whether to evacuate 3 million people. They got to evacuate 3 million people from the coast. And they do what's called vertical evacuations. They have to make that call when the storm's in North Carolina. So you got to have a mayor with some guts. And you know, emergency planning officials in Ocean and Monmouth, you know, and Atlantic County, and further inland too, to make the call on some of this stuff. So you make a plan, you put it in a book, and you put it away, because you don't have time once the storm starts coming. Because everybody else is going to be running like a chicken with their head cut off. So, sign books. That's scary enough.